Hi, I'm Dave Watts. Welcome to the fifth part of GSA 100, Secure Search with Kerberos. In this session, we'll learn about Kerberos, what problems it solves, how it works, and how to use it with the GSA. Our focus for this session will be in Windows and Active Directory, but Kerberos can also be used with other environments. In Windows domains, Kerberos or NTLM can be used for silent authentication. Kerberos is used automatically in Windows where possible because it is more robust and secure, and we prefer to use it because it can be set up directly on the GSA. However, there are a couple of reasons that may prevent Kerberos from being used on the GSA. We'll discuss these as we proceed. If you need to use NTLM authentication, or you cannot use Kerberos configured on the GSA, you need to install an ASP.NET application called the SAML Bridge for Windows on another server. We'll discuss this later in other training. If possible, again, you should use Kerberos instead of NTLM. The purpose of Kerberos, in brief, is to allow user authentication against a central server over a trusted network, for example during network logon, then allow user authentication against other services over untrusted networks using the user's initial authentication ticket and a service ticket unique to that service. The central server that dispenses authentication and service tickets will, of course, be your Active Directory domain controller, which in Kerberos terms will be our key distribution center. To enable the GSA to work directly with your Kerberos Windows domain, it will need to be Kerberized. To set up other Windows servers to work with a Kerberos Windows domain, it's usually sufficient to simply join them to the domain. Because the GSA doesn't run Windows, we will have to manually do what happens when you join a Windows server to a domain. We'll need to create a user account in Active Directory that represents the GSA. Then, we'll elevate that user to a service principal and obtain its encrypted server token called a keytab file. The keytab represents the service principal user and allows the GSA to crawl content as the service principal and decrypt service tickets for end users. Sometimes administrators will not allow you to create keytab files for the GSA. If this is the case, you can use the SAML bridge to use Kerberos on the GSA without a keytab file. For instructions on how to do this, see training in later courses on the SAML bridge. Before we discuss Kerberos with the GSA, let's look at how end users use Kerberos with an IIS server. In IIS, you enable integrated Windows authentication. This will configure IIS to attempt to use Kerberos with browsers and to use NTLM in the event that Kerberos negotiation fails for any reason. Kerberos authentication must be silent, so the user's browser will also need to be configured not to prompt the user for credentials. Instead, it will automatically get and pass a service ticket to the IIS web server on the user's behalf. For Internet Explorer, this is done by placing the IIS server in the local intranet zone. Chrome is configured the same way. Firefox has configuration entries that will need to be added or changed within the About config file. Sometimes administrators will not allow Kerberos to be enabled in users' browsers, or some users may be outside the firewall. Kerberos does not usually work across firewalls. If this is the case, you will not be able to use Kerberos on the GSA. However, you can likely substitute NTLM for silent authentication using the SAML bridge. Since both Kerberos and NTLM support silent authentication, how do we know which is being used? We need to verify that we're using Kerberos before we configure our GSA to use it. One way to tell is by examining the HTTP requests and responses between the browser and the IIS web server. The initial request will typically have no authorization header. The web server will then return a 401 status code indicating the user is not authorized. That response should include two www authenticate response headers, negotiate and NTLM. Those tell the client that it should try to use Kerberos, but if that fails, use NTLM. If the client supports Kerberos, it'll send a second request that contains an authorization header. This header should contain the word negotiate, followed by a long string of characters. Note the name-value pairs embedded within this string. There are actually three possible outcomes. Negotiation succeeds and Kerberos is used. Negotiation succeeds but unprompted NTLM is the fallback. And negotiation fails with NTLM prompting the user. If the string contained encrypted values, it may be an NTLM token instead of a Kerberos ticket, even though it says negotiate. And of course, if the authorization header says NTLM instead of negotiate, we know it's using NTLM. Another way we can look at Kerberos information is from a command prompt. The klist command with the ticket switch shows the user's tickets. Here we can see two tickets. The first, with the prefix KRBTGT, is the user's initial authentication ticket received from the Active Directory server at network logon time. It's called a ticket granting ticket and is used to get individual service tickets from the AD server as needed. The second, with the prefix HTTP, is a service ticket to allow the user's computer to talk to a specific IIS server. In this case, shanghai.learngsa.com. This is evidence that Kerberos authentication for this service occurred for the user. Let's take a look at a Kerberos environment. To be Kerberized, a Windows workstation needs to be a member of the domain using Kerberos. So I'll do this on a remote desktop within that domain. First, I'll take a look at the tickets on this machine. To do this, I will use the klist command with the tickets switch. And that comes back with 7 cached tickets. Some are duplicates. The first 2 are ticket granting tickets. Those are retrieved from Active Directory, and they will allow me to ask for other tickets in the future. Next, I have a file system ticket, CIFS, a couple of LDAP tickets, another file system, and then this host ticket, which allows me to be logged in locally. So to access any of these other services, I need the individual service tickets. The last 5 of these are service tickets. Now, at this point, I'll open a browser, and you'll notice there are no HTTP tickets in here. So I'll go ahead and open a browser. I'll use Firefox for this. And I will initially just go to shanghai.learngsa.com. This is the site that uses integrated Windows authentication, and it's prompting me for credentials. So right off the bat, I know that I don't have to look at any headers. This is not using Kerberos. I'll simply escape to cancel my authentication, and now I'll configure my browser to support Kerberos. To do this with Firefox, we edit the About config file. And specifically, we're looking for a header that contains negotiate. So I can type in NEGO. And then the specific one I'm looking for here, network negotiate auth trusted URIs. I'll double click on that and add in my entry. If I want multiple entries, I just put in a common delimited list. In this case, just the one, shanghai.learngsa.com. Now, once that's in there, I can go back to Shanghai. Now, you'll notice I got this error message, but I was not prompted to log in. So I can see that silent authentication is working. But am I using Kerberos or NTLM? There are a couple different ways that I can look at that. Because I'm using Firefox, I've got a plugin here called Web Developer, and it allows me to see request and response headers. Now, simply looking at this, I can see I got a response header, negotiate. So I can see that IIS is responding properly. If I go back to my command prompt and rerun klist with the tickets argument, you'll notice I now have another ticket, HTTP for shanghai.learngsa.com. So that is the service ticket that I just got to talk to that web server. Now that we're sure we're using Kerberos for users accessing back-end content sources, we're ready to Kerberize our appliance and crawl the source. The first step is to create a user account in Active Directory. When you join a Windows machine to a Windows domain, a hidden user account is automatically created for you in Active Directory. We'll have to create ours manually. Then we'll have to elevate that user to a service principal by running a ktpass command on it and generating an encrypted token containing the account and its password, and then install that file on the GSA. That token, as mentioned earlier, is called a keytab file. If we're using back-end head requests for user authorization, we'll also need to revisit the GSA service user account in Active Directory and enable a specific feature called delegation. The GSA will have to impersonate end users to back-end content servers and find out whether a user can see a specific document. In Kerberos, this kind of impersonation is called delegation. The simplest approach is simply to enable delegation to all servers. In addition, if we want the GSA to use this account when crawling content, we'll have to enable Kerberos crawling on the GSA. This is done under crawler access. The user in Active Directory will need read access to all content to be crawled, and you can only have one user account associated with the GSA for Kerberos. Once all of this is done, just add the URLs to crawl URLs and let your GSA crawl them. Your GSA's user account will need to have some specific settings. The password can't expire. If it does, you'll need to regenerate the keytab file. Also, you'll need to know the encryption types supported by your Active Directory environment. If you're using DES, you'll need to specifically enable DES encryption support within the user account. DES is old and fairly weak and isn't recommended for use in most cases. Most modern Windows environments support RC4 encryption. You can optionally specify all here if you're not sure which one you're using. Next, you're ready to create your ktpass file. If you're using an older version of Windows, you may need to download the Microsoft support tools for that version to get ktpass. The ktpass command line utility will create a token that can be installed on a non-Windows server running Kerberos that will let the server participate in the Kerberos realm. Before you proceed, make sure you have a valid service principal name for your GSA. By default, if you're using Active Directory for DNS, this will correspond to the A record in DNS for your GSA. However, it's pretty common to have an A record with a complicated name and a C name record to allow user-friendly access. You will either need to use the actual A record instead of the C name, or manually create an SPN that links the C name to the A record using the set SPN-S command. You can also use set SPN-L to verify that the SPN for your GSA is correct. Once that's verified, run ktpass with the correct case-sensitive arguments to create your keytab file. The first argument specifies the protocol of user requests, the service principal to create, and the Kerberos realm. The Kerberos realm likely matches your fully qualified Windows domain or user principal name suffix of the service principal. The second argument maps the Active Directory user account to the service principal name. The third argument is the password for that user account. The fourth argument specifies where the keytab file will be placed. The fifth argument specifies the encryption type the GSA must use when communicating with the realm. We have a short list of encryption types supported by the GSA in Windows here: DES, RC4, and AES. The sixth and final argument for ktpass is optional. If you omit it, you'll receive an error message, but can safely disregard it. There's a lot of things you have to do to create a keytab file. To make this easier, you can download the self-help tool from the GSA Admin Toolkit. This is a simple .NET application that will take an account you've already created in Active Directory and configure it as needed, then create the keytab file for you when you click Create. If you're using back-end head requests for authorization, you also have to configure delegation for the user account in Active Directory. Now, for ktpass and Kerberos to work, time will need to be synchronized between the GSA and all the other machines in the domain. In a Kerberized environment, time synchronization is very important. In a Windows domain, all machines synchronize with the Active Directory domain controller, but the GSA doesn't do that and can't be easily configured to do it since Windows doesn't include an NTP server. Your GSA should be configured to use the same NTP server as your Active Directory controller, or you should install an NTP server on your Active Directory server and point the GSA to that. To test your keytab file, you can use the Kerberos validation tool, which can be downloaded and installed on your machine. This is available as part of the GSA admin toolkit, along with the GSA Kerberos test client written in Java. And the GSA documentation for troubleshooting Kerberos lists several other tools you may find useful. To install the keytab file, navigate to your Kerberos tab in Universal Login Auth Mechanisms and enter the host name for your KDC, which of course is also your Active Directory domain controller. If you're using cross-realm authentication with other domain controllers, check the option to enable KDC DNS lookup. Then click the Save button. Next, use the Choose File button to select your keytab file, then import it. Finally, select a credential group, check the Enable Kerberos Support checkbox, and enter a mechanism name. The mechanism name can be anything as long as it doesn't match a previously used mechanism name or credential group name. If you're using an older version of Windows and are also using DES, check the Allow Weak Crypto checkbox also. Then click Save. At this point, assuming your keytab file has no errors, you should see a series of messages at the top of the page indicating success. The GSA can now use Kerberos at serve time for user authentication and possibly authorization. If you want to use Kerberos for crawling, go to Crawler Access and check the box to enable Kerberos crawling. As mentioned earlier, the user account associated with the GSA must have read access to any files you want the GSA to crawl via Kerberos. You can very quickly test Kerberos crawling for a single URL from real-time diagnostics using the manual fetch request. Let's set up Kerberos on the GSA for crawling and serving IIS content. First, I'll create the service user account in Active Directory that matches a DNS-A record, make the password never expire, and specify an encryption type. For this, I'm going to need access to the Active Directory server, so I'm logged into that right now. I'll open up a command prompt, and the very first thing I'm going to do is figure out what is the A record for my GSA. My GSA is GSA1, so I'm looking for that. Now, of course, if I just ping that, just for fun, it's going to give me back an IP address, but it doesn't tell me whether it's a valid name. So NS lookup will let me do that. And that tells me it is a valid name, but it doesn't tell me it's the A record. So I have to ask in a little more detail. So I can see here that it is in fact an A record by asking the DNS server. So that is what I'm going to use as my service principal name. So now I'm ready to create my user account. For this, I'll go to Active Directory Users and Computers, and I'm going to create a user account. I will call that user account GSA1. So to create my user account, I'll just use this little new dialog, new user. The user login name will be GSA1, and you'll notice that we have the realm listed over here, ad.learngsa.com, and we also have the domain/user syntax, so we can see that as well. I'm going to give it a password. And I want to make sure not only can the user not change the password right now, but that it never expire. So now I've created my user account. Now I'll go and look at the properties of that account. And I sure have a lot of tabs here. I'll go ahead and take a look just for fun at the account tab. And scroll down, and you'll notice there's an option here that says use DES encryption types for this account. So if I were using DES, that's what I would enable. Now, to create the keytab file, I'll need to open up a command prompt. And there are actually, of course, two ways I can do this. I can do this manually, or I can use the self-help utility. And just for a minute, I'll pull that up. So if I go ahead and go to the self-help utility first, I can specify my host name, gsa1.learngsa.com. I can specify my username, adgsa1. And I can specify my password. And you can see how this is going to build the ktpass command for me. Of course, if I felt comfortable doing this, I could just go ahead and run ktpass myself directly. I can take this text, and you'll notice that it lists for crypto, it lists all. I might not want to actually use that. Now it also doesn't know my DNS realm, so I won't be able to use that output as is, but it did do most of the work for me. So I'll use that as a reference, and I'll run my ktpass command. Now if I just type in ktpass, and pass in -H, it will list the different types of encryption I can use and all the other different arguments as well. And I'll just move these things around a little bit on my screen so I can see them a little better. There we go. So first I'll specify my service principal. I specify the type of service. This looks a little bit like a URL, but it really isn't. HTTP is the service prefix. And my realm is actually ad.learngsa.com. When I created my account, I saw that as the service principal name suffix. I can name the out file anything I want. This will create it in the directory from which I'm calling ktpass, in this case, C downloads. The P type is optional. It will give me an error if I don't include it. So just to get rid of the error message, I'll specify it. Now, be careful when you're doing this. Make sure you review all of your arguments carefully. Make sure you have your server A record, the service principal name, Kerberos realm, the pre-Windows 2000 login syntax, the password, the out file that you want to create, the cryptography and hashing algorithms you want to use, and optionally the p-type. Once I'm satisfied, I can click on Enter. And you'll notice I got an error message right at doing this. I did not specify the realm in uppercase. And that's something that the self-help tool shows me, but I didn't pay attention. So let me rerun that command. With the correct case for the realm. Now, once this is done, it's going to map internally, it's going to map that user to the service principal name. So the ktpass file actually has an effect on the Active Directory server itself. In addition to just creating the file for us, it also changes settings for that user account in Active Directory. If I go back into Active Directory users and computers and look at the user properties, I should now see a delegation tab, which I didn't see before. And if I want to use authorization and impersonation, I'll need to choose the option, trust this user for delegation to any service. So I'll make that change. Now I'm ready to upload the keytab file to the GSA. So I've logged into the GSA admin console. I'll go to Search, Universal Login Auth Mechanisms, go to the Kerberos tab, and the first thing I'm going to do is put in my KDC hostname. I'll go ahead and save that change. I'll browse for the file that I want. gsa1.key. So I've imported my credentials. And I'll enable Kerberos support. Give it a mechanism name, and use it as the default credential group. Now, if I was using DES, I would check this box. I'm not, so I won't. Now, once all three of those things happen, I should see at the top of my screen 3 green lines. Now, I do want to make sure I'm not using anything else with the default credential group. So I'll go ahead and delete my LDAP rule from earlier. You can have only one authentication agent per credential group. But Kerberos is now configured for secure serving. Now, if I go back to my content sources and go to crawler access, I can enable Kerberos crawling, and this will automatically send the GSA's credentials to content servers when challenged with a negotiate header. That'll take a minute to load up. Once it's done, I'll configure the GSA to crawl my Kerberos content. Now on Shanghai, I actually have different web servers on different ports. the one that will work for me here is on port 83. So I'll specify that for both the start URL and my follow and crawl pattern. Now I can test this pretty quickly by going to real-time diagnostics and putting the same URL right in my manual fetch request. And assuming it works, I should see something like this: an initial request without credentials, followed by a 401 challenge with the negotiate and NTLM response headers, a subsequent request, and it's not going to show me what the authorization value is here, but I can see that there is one, and finally a 200 response with a negotiate response header showing information. So this indicates that I was able to connect successfully to that URL. Just like we had to configure our browser to use silent authentication with our IIS servers, we'll also have to configure it to support the GSA. In IE or Chrome, we'll need to add the GSA to the local intranet zone that we're using with other Kerberized servers. In Firefox, we'll have to add the GSA to trusted URIs. And if we're using the GSA for late binding authorization, we'll have to add it to delegation URIs also. In all these cases, the specific name we'll have to add is the GSA's service principal name, which corresponds to its A record in DNS. Next, I'll configure the in-browser to pass Kerberos tickets from the browser to the GSA. Since I'm using backend head requests for authorization, I'll also need to configure the browser to trust the GSA for user impersonation, or delegation as it's called in Kerberos. So since I'm using Firefox, I'll need to open About Config, and again I'm going to look for preferences that have NEGO in them. And I already have one for trusted URIs. I'm going to go ahead and add gsa1.learngsa.com to that list. But I'm also going to have to add GSA1 to my delegation URIs. This will allow the browser to pass a request to the GSA that will let the GSA pretend to be us when it talks to the content server. Remember, the GSA is trusted for delegation. Now, I can test this very quickly. Of course, I already know how to test it directly against the server. If I click on this, it takes me to Shanghai on port 83, and I'm able to get in without manually providing credentials. That indicates that I can connect to that web server with Kerberos. Let's try the GSA. So I'm going to run a search for secure content, and I'll use the pattern in URL :Shanghai as an easy way to get things from the Shanghai server. And here we go. We can see that I'm getting quite a few results back, and I wasn't prompted for credentials by the GSA. Now, how do I know that I'm actually using Kerberos here? Well, there are a couple ways I can tell. One is to look at request and response headers. Another is to look at our tickets. So I'll look at my tickets again. And you'll notice that I have tickets for both GSA and Shanghai. So clearly, I am using Kerberos to talk to those via HTTP. And of course, I can also go to serving logs and look at some information about my query. So I can see the Kerberos authentication process. It wasn't able to find any groups associated with my account. That's okay, but it was able to authenticate me successfully. Now it's using the head requester to get all of these documents. So there were quite a few, none that supported ACLs, but quite a few that required the head requester. So the GSA is pretending to be me. It's taking my service ticket to talk to Shanghai. It's sending that service ticket to the Shanghai server on my behalf to figure out which documents I'm allowed to see. This concludes our 5th presentation, Secure Search with Kerberos. Thank you for watching, and make sure to watch the other GSA 100 presentations.